Today's lecture is about the section views and about the views. Okay, so section views, auxiliary views, how to make auxiliary sections, broken out section, how to make symbols in the drawing. Okay, the section views. If you've seen on right hand side, there is the flash, and you can see here in inner components is highlighted. So outer body surface or outer part is made it kind of transparent, and inside inner components are seen. You can see here, but this is a CAD assembly kind of view. But when you draw in two-dimensional sheet, in order to be able to show inner components, we need to make a section views. Okay, so we cannot make a transparent things in the two-dimensional drawings. So that's why there is the method called section view making. Okay, so section view generation to show what's inside. Okay, so there is three main purposes in order to make section views. Okay, so those are to document the design and manufacture of single parts that the manufacturer is one piece. So to know, is it one piece, is made it from one piece or from several pieces. Okay, so it's assembled kind of from many pieces. So to show that one, we need to make a section view, and you can see here in the bottom right hand side bottom. So it's made it with using a plane. It's made a kind of section plane, cut it with using sectional plane. It's made it section views. So you can see here inside components are connected or not. So connected components means is kind of a single part. If it's not connected or it's not a single structure, that means that is assembled. Okay, so to show whether one piece or several pieces is constructed from several pieces. Okay. The second thing is to have a section view is to document how multiple parts are to be assembled or built, to see how is constructed, how is assembled. Okay, so which one is first, which one is secondly mounted, and which one is thirdly. So how they mounted together. Okay, the third one. So here you can see the inner components are shown physically. The Porsche 911 Carrera. Okay, so the car inner components are shown same like a sectioning assembly, like a physical model. To understand, okay, so I put this one to understand. It's not a sectioning. That's just physically sectioning, that one. So same thing happening with drawing. Okay, and the third one. So first one, second one, third one. Okay, so first one is to document the design and manufacture of single parts. Okay, the parts are made it from single part or not. And second one is how many parts are assembled together. Which one is first, which one is second, which one is third one. Okay, so how they are constructed. Okay, so which one is outside, which one is inside. The third one is to aid in visualizing the internal workings of a design. How, okay, to see what's inside. Okay, so to visualize the internal workings. So where is the structure elements, where is electronic elements. Okay, so inside, what kind of materials are there. But to see those things, we need to make a sectioning. Okay. Okay, so next. There is a types of sectioning. So the first one is half sections. Half section is similar to this one. So this one. Okay, so something like this. So the full part, okay, so without any sectioning, is initial part is given like this. in the space, in 3D space. Okay, so in reality, can I say? And in the drawing, we draw like this way. So if you see here, we are looking from this side, and this hole is here. So we have a center line. So center line is drawn here, like, okay, this one. Center line is drawn because this is cylindric object. Okay, so if you have a cylinder or cylindric part, so we have a center line. We have to draw a center line. So okay, dash dot line, long line, dot line, and then long again. Okay, so we call chain line or dash dot. So several, there is a names. Okay, so chain line or center line, or both are correct, or all are they are correct. Okay, center line or dash dot line. Okay, so then the inner, there is an inside the empty. Okay, there is a hole inside here, and also here the feature like this. Okay, so groove area. So to show these informations, we have a dash lines here. Here you can see here dash line. Okay, dash line. So we have this one. Just we can say dash line, dash, or hidden line, hidden feature line. Okay, so hidden edge to show the hidden feature. We have this kind of hidden line,
which is the unusual parts of
yes, right.
detail.
From outside is invisible, so you cannot see from outside, but it exists inside. So we have a two-dimensional drawing, so that's why to show this one we need to show we need to give that information to the engineer. Okay, so to the other people. Okay, so all our dash lines here. So this edges are made at this kind of dash line, and this hole made at this kind of dash line. And so inner, there is a, in the bottom is bigger hole, more bigger than the top one. So that's why. So you see here that another edge is made it as a base of the hole from the bottom side. Okay. Okay, so that is just original part and original drawing. Okay, so for this one, without any sectioning. Then in the half section, we're making a only quarter part is cut. That cutting is just for imaginary. Okay, so it's not real cutting. We are not cutting in reality. Okay, so just just imagine you cut, and what you see on this plane. So you see this area. Okay, so this area is the physical area is cutting, but here it's not touching to this plane, right? So this in this plane, so in this plane is what will touch. So only this area is touching. But here is not touching because it's a little bit far away. Okay, so a little bit behind. So that's why this area is not touching. So the yellow area is not touching. So this area is not touching. So that's why we have to show like this way. Okay, so the area which is touching to this given plane, the sectioning plane, so it's hatching this. We call this one section line. Okay, section line. We're drawing this kind of hatching. Okay, so section line, or we call hatching. So we are hatching the area which is touching the plane, which is not touching, just remain as without fill. Okay, so unfilled, just leave it, no filling inside. You have to fill the area which is touching the plane. So this area, okay, this plane is not, we cannot see because we are seeing from this side, so there are no plane. Okay, so that's why you just remain only the chain line. Okay, so no any solid line. So there are no solid line, just only remain chain line. Okay, so if you do solid like this line, that is wrong. Okay, so the outside, the another half, this half is just remain like outside. That means this side. Okay, so this side is outside part. You see same like this one. Okay, so this original part without sectioned. Okay, so without section just remain. So only half is sectioned. So half part is sectioned. Okay, so in reality that is 1/4, the quarter part. Okay, so 1/4 part is sectioned. Okay, so and you see this what from this side. Okay, so what you see here, that calls half section because you see half half side sectioned in 2D. Okay, so the second type is broken out section. Okay, so just let me say, when we use a half section, we use a half section when we have symmetric objects. Okay, so when we have symmetricity parts, okay, if two parts are symmetric, two half are symmetric, so you can use half section, and half you show with section and half without section. So in this case, you will see outside part of the part and inner features of the part. Okay, so with half section. And the broken out section without having a cutting like this, so we are breaking. Okay, so breaking some area, just we are some break out some area and see what you see inside. So inside we see, so we are looking to this direction. We have this kind of broken out line. So this kind of broken line or wavy line, say, okay, broken or wavy line, wave, kind of like this line. Okay, so wavy, with using wavy line, we are showing there is a breakage. Okay, so broken out place. And what's inside, so this area, so it should be hatched. Okay, should be hatched. Okay, so outside you remain like original shape. Okay, so like original shape, just remain with dash lines, with everything. And another thing, when you have a half section, when you show inner features like this, the another side we show outer features, right? So here every hidden features like these features, hidden lines are disappear. Okay, so because we don't need to show them because we already show on the section side. Okay, so in this side we show inner components. Okay, so inner elements, inner edges. So that's why no need to have here hidden lines and hidden feature to show the hidden features. Okay, so that's why that will disappear on this side. So one advantage of the sectioning is to have to eliminate, to remove these lines. Okay, so we don't need to show that lines, so that makes easy to read, easy to understand the part. Okay, so just only to show on the side of the, okay, so section side, and then so remove the other hidden lines, so that will make easy to understand who is reading this drawing. Okay, another type is offset sections. Offset sections, I will have another slide. Offset sections in another slide. There is a type, another type is revolved section. We have another slide, removed section, another aligned section. So full section. So half section is just only one half. We have a in the drawing, half part is section, but full section is when you have the big plane, and fully we are cutting, we are sectioning fully the object. Okay, so both sides are sectioned like this way. Okay, so there are no outer shape is shown in this way. Okay, so full section is fully, you are cutting fully. Half section is just only one half. In reality, that is 1/4. Okay, so 1/4 is cut. It's section like this way. So let's see this offset section and revolved sections in the next slides. So this is offset section. In offset section, we are having 2 and more planes with some given some distance in between. Okay, so here we have a plane 1, and there is another plane 2. So in between there is a distance. There is an offset distance. Okay, so we are offsetting a plane. So it's not a single plane. It's it comes with many plane. Okay, so here the purple part is given. So and purple part has features. Okay, so there is a cylindric hole. Okay, so this is a cylindric hole, and this is a rectangular prismatic hole. Okay, so rectangular hole, and rectangular hole. Okay, so to show this inner features, edges, we are cutting with planes passing through these 2 objects. Okay, so this is so it's near to us, so we are looking from this side, right? So it's a little bit near to us than this one, the second one. Okay, so that's why we are cutting with this plane here, and another plane with here also. And how to show? Okay, so if you see from the top, it's something like this. So this one is cylindric thing, and this is a rectangular square prism hole. Okay, so we are cutting with this way and go up and like this way, and we are removing this everything here and looking from the bottom to top. And what you see here, we have like this thing. So here we have a cylindric. How to know that is it cylinder or not? So because here we have a center line. Okay, we have a center line here, and the second thing is here we have a square shape. Okay, square hole. So that's why there are no center line. Okay, to understand the differences with center line and with not. Okay, so and all other things are hatched. Okay, so unhatched places are empty places. Okay, so there is no touching to the nothing is touching to the plane, to cutting sectioning plane. So the things are touching to here is touching, here is touching. Okay, so that's why it's hatched like this. Okay, so the field with hatching line or section line. And how about here? We are turning to the upper side, so there should not be anything. Okay, so in some cases students are making a line here like this, like solid line, so that is wrong. Okay, so it should be no any line, and also in offset section we'll have or any section line in the drawing, we have this kind of solid line and solid line here, and then the direction of viewing with given with arrows here. Okay, so arrow, and also the turning here, turning of the plane. Okay, so should be shown with solid line, and that is continuous line, but is more thicker than original this continuous line. Okay, so it's more than thicker more than this. Okay, so more thicker. Okay. Okay, so here the example. In here we'll see the example. Okay, so in this the bottom left hand side. Okay, so example. This is top view of the shape, and top view is sectioned like this way. Okay, so we are cutting and we are going up, cutting again to the right hand side, cutting until here, and then go up and cutting in order to show this inner hole, and go down and then like this way. So all bottom side is through out. Okay, so we don't need this, and then we are looking to this side because here the arrow showing like this way. And what we see is yeah, the solid thing, and this is front view, but front view is replaced with section view. Okay, so if you have a front view and section view outside, okay, water features are similar, you can replace the front view, and instead of front view you can set, okay, you can show the section view AA. Okay, so we're cutting with AA plane. Okay, so that is AA shown here, right? AA here. And then if you have another cutting plane or section plane, you can show, okay, so if you cut like this way, something like this. So, and you can put some arrow, okay, and you can write BB and show somewhere, you can draw it, and then you have to call it like BB. Okay, so we're cutting with AA, and here is solid part, so that's why it's hatched here. Okay, so you can see here is solid inside. So empty area, this one, empty area, because that is cylinder, so here you can see center line. And also solid everything here until here. And to show that in this one, rib is not sectioned. So there is a rule to show the feature, okay, to make easy understanding, that narrow ribs and webs should not be sectioned. Okay, so this is narrow area, so that's why we are not sectioned here. But to show inner, there is a hole, inside there is a hole. So to show this one, we have this kind of wavy line here and broken out section. Okay, so made it broken out local sectioning, and to show inside there is a hole and there is a center line in this at the center. Okay, so then we're continuing cutting. So it's here the solid area, and empty area inside. So empty area here, and then solid area again. The very narrow things like webs and ribs and some structure, the narrow things should not be sectioned. So that's why it's not sectioned here. Okay, so no hatching inside. And there is a rule. And we are going to this side and turning to show the inner component, inner hole. So there is a inside, there is empty, please, a little bit, and then inside a hole to show this one. And then also to show this one, we are turning to this side and then cutting to show this element. Okay, so this is a rule. That's a way. Okay, so that is an offset section. You can use like, yeah, the one plane, second plane. You can use third one also. Here we use, okay, one plane here, second plane is here, and third one is here, and fourth one is here. So we have used one plane, the second plane, the third one, fourth one, 4 planes in section. So you can use many planes also, but you can use at least 2 planes in offset section. If you use one plane, so that becomes a full section. Okay, so that's offset section. That's offset section. Okay, revolve section. Revolve section we use in long objects to show the cross section of long object. The cross section of elongated objects may be shown by revolve section. Okay? how to do this. Just there is a way. Um, there is a way. So in this example, we did kind of the cutting. Okay, so this we call removed section. This one. Okay, so we're cutting with a AA plane, and we are removing in some area, in some place on the side of the drawing, this cross section of this area. Okay, so how it looks like in when you cut. So it looks like this. That is we call removed section. Okay, so removed section. Similar to this one, without doing this or just to eliminate this process, or to without having, you know, just this kind of drawing on the side, you can do just without moving it. Just what you see here, just you can draw inside with having thin lines, and you can hatch it inside. Okay, like this, like this. So that calls revolved section. Just you're cutting and revolving to 90 degree and showing it. Okay, so like this. So you're cutting here with AA or any section, and then you're revolving it, okay, rotating it 90 degree. And what you see, you draw it here, you draw it here. So that calls revolved section. Okay, so we are revolving, we're revolving. So there is a difference. There is a difference. So if you, when you revolving and you're drawing, so you have to disconnect this feature. Okay, so outside feature, you have to disconnect it. So here is an arrow. Here's the arrow. So you have to disconnect it like this. Okay, so it's disconnected. So that's correct. So if you continue like this, that's wrong. So that means, so we are going inside the section. So in the section, you are not seeing this kind of edge. So that's why you have to disconnect it. You have to remove this edge. Okay, so in the area of revolve, okay, section. Okay, so that's wrong. That's correct. And also in this structure, like, okay, so from the side view or front view, you're seeing, so here a cylindric part, cylindric place, and cylindric part here, and inside there is a hole, inside the hole, and here is a slope. When you cut, you will see this kind of cross section. Okay, so you have to draw what you see. But if you make just without doing like this straight, okay, just like this line. So when you do without changing it, just what with kind of a slope, that's wrong. Okay, so that's wrong. So you have to draw same like in reality. So you in reality you will see this kind of straight line, not the slope. Okay. When you, okay, the slope, and we are cutting, and when you cut, you will see here the straight line like this. Okay, something like this. So there is a slope, you will see here like this section. So even though this one is a slope from the side, but if you see from 90 degree, so the blue area, so the blue area, so this line is straight line. So to okay, you have to show that straight. Okay, and so that means that's correct. It should be like this, and it shouldn't be like this. Okay, so that's wrong. So the wrong thing is that's not straight, and also it's not disconnected here. It's not disconnected in these corners, in between these corners. Okay, so how about this one? So how about this one? How about this one? So we'll see in next slides. Okay, so we are making, okay, we are cutting, and we are cutting here, and we are rotating it. Okay, we are revolving it. and showing it with breakage. The revolving section shown with broken out line. Okay, so broken out line shown here, and broken out line shown here, and then we revolved 90 degree and showing what we see like a cross section is like this, and it's given with again with hatching or with section line. Okay, so the both are correct. This one, this way also correct, and that way also correct. Okay, so this one and that one is revolved section, and but this one is removed section. So we are removing somewhere the cross section removed somewhere. Removed section. So okay, so a removed section is one that is not in direct projection from the view containing the coupling plane. So we are not showing here in just the coupling. Okay, so in the place of the coupling, just we are removing somewhere. Okay, we are placing, we are we are moving somewhere else. Okay, so, the section. Okay, so you can we are placing somewhere, and also if this one is very small part or small view, so you can make it with we can scaling it. Okay, so you can make it big view, like scaling. Okay, so 2 times, 3 times, 4 times, 5 times. Okay, so you can make it big view. So here the 3 examples are shown. So this one is used like this plane. Okay, so to cut, and what we see, so this is direction. Okay, so direction of the watching. Okay, seeing. So what we see here drawn here. Okay, so section AA, and 4 times is multiplied. Okay, so 4 times is zoomed. Okay, so 4 times is bigger than reality to show what's inside. Okay, so inside inner component, and everything is shown with dimensions. So because this one is the detailed part view. Okay, part drawing, detail drawing. So that's why it's shown with every dimension to in order to make this part. And another example, and this is the first example, and second example. So hook part is cut like this, and if you see here, you will see this kind of on this side. So sorry, this one is like this. It should be like this. We're cutting only from this side, and then what you see here in this area, we'll see this. Okay, so we're cutting like this, and okay, the cross section is like this. Cutting like this, and cross section is like this. We can do like this removed section. Or shaft is shown in third example. We're drawing like this center line or just chain line, and cutting here, and watching like this, and what we see is this, and cutting like this. Okay, so this, and watching to this direction, or this another direction also possible, and this is what you see. And also, what's this one? What's this one? That means when you see from the top, so you will see this kind of area. Okay, so empty area. So this one is shown here. It's also in the center. And also we're cutting here. Okay, what we see is this. It came with thread. Okay, so we'll have a lesson for threading. So threading area. Okay, so that is a removed section. So okay, align section, removed section. Okay, so we have studied revolved section and removed section. So we need a align sections. Align section. Let me show the align section. Okay, In the aligned section, actually, aligned section uses for cylindrical objects. Okay, so for the mostly in cylindrical objects, to show the components, the features of the part, we're cutting with one plane up to the center, and with another. Okay, so the plane one, and with another plane also it should be passed through the center, so second plane. And to show this thing, so what we see, okay, direction of looking here, direction of looking from here, we are throwing this side, okay, through it out this part, and see what you see in first side and second side is aligned. Okay, so this one is rotated until this center. Okay, this line. Okay, so centricity line, and this one also rotated until here. Okay, so two sides are rotated into the one plane until it becomes a plane, and then that will show. So like this thing. Okay, so this half is what you see from the first plane cutting side, and another right hand side is shown to the as a result of cutting of, okay, sectioning of second plane cutting. Okay, so it's aligned. Okay, so the planes are aligned. It's not cutting and just what you see here is not drawn like this way, and then the behind what you see. So it's not like that. So what you see here, that is rotated until this one plane. Okay, so one line, and that is also rotated, and this one is rotated until here, and then what you see it is shown here. So that calls aligned section. Okay, so let's see other information, and then I will have a video information for you. So in some cases, the planes are not parallel to the projection planes. As we started to you, there is a 3 planes, right? 3 projection planes. So if you see in the space, there is a 3 planes. So H plane is horizontal projection plane, and frontal projection plane is V, and profile projection is W. So in some, okay, so some objects might be parallel, some sides of the object might be a parallel with one of this, but in some cases it might not be a parallel. The side of the part might not be parallel with any of them. So then we will have, what we have is we will have a create the auxiliary view, okay, in order to see the true side of this. Okay, so because if you project it to this side, that comes with a slope, so that's why you cannot see real length. Okay, real length of this. Okay, so the length is not real in here, because we are looking to this side, and because it is turned to the side, so that's why it will be projected without having a real sizes. And to this side also, that will be projected differently, not like original part. Okay, so because it's turned a little bit, and from the top side, that might be projected some like original, but in our case also it might not be real true view. Okay, so we call true view this real view. It calls a true view. Because it's turned in 3 sides also, so that's why we need to create a view for this side to show this to project this side. We'll create a true okay, we'll create an auxiliary view, something like this. Okay, so this side is okay, so that is parallel with projection plane, and that is also parallel. So this side and that side are parallel, so this top side. But okay, so we can project it without having any auxiliary view for this. But if you see here, it's not parallel to any of them. So that's why we are making a plane, auxiliary plane. So this is 3 plane. We are making a 4th plane, okay, plane number 4, to parallelly to this side, and then we are projecting everything to this plane to see this side. So original, like as is, okay. So the side same like regional view, like true view. Okay, so same, we are making a plane. We are watching from the top to this. Okay, so when you see from the top, you will see this kind of thing. And also we are making this side is, okay, so this side is this, you will see as a line. So we are making a plane to the parallel to this line, and then projecting everything, every side. Okay, so we are referring every corner from this top view drawing. Okay, we are making referring every side. So we are making 90 degree lines, and also passing through this corner and all informations from top view, making, okay, we are finding these points, and referring this information, we're making this kind of auxiliary view. In this auxiliary view, this side is like in reality, so we are looking normally to this side. Okay, so that means when you refer, in order to have this one, we need to have auxiliary view or auxiliary plane. So we use this information. Okay, so this thing, there is a types. Okay, so auxiliary views, any view obtained by orthographic projection onto a plane other than the horizontal, frontal, and profile projection. Okay, so there is a standard projection planes like horizontal, frontal, and profile. So other than these planes, okay, so any other projection obtained to other planes than these 3, that calls auxiliary okay, plane or auxiliary view. Okay, so and there is a primary auxiliary view and secondary auxiliary view. Okay, so a primary auxiliary view is projected onto a plane that is perpendicular to one of the principal planes. So one of these projection planes like horizontal, frontal, and profile. So any, okay, to this perpendicular to the okay, the view of the projection, and is inclined to the another to the other two, that calls primary auxiliary view. Something like this. Okay, so the view is perpendicular to the P plane. So here, so object is given inside to make you understand. Okay, so that's the frontal view, and that's the top view, what you see in the top view, and that is auxiliary view. So we are looking to the to show the P plane, or it just is as a true. So we are making auxiliary plane here like this, and we are referring that information from the top view or horizontal plane and frontal plane. Okay, so we are opening. Okay, so we are opening it like this way. So to generate this one, so you need to make a parallel to the what plane like what you wish. Okay, so I wish to make a view of this, to create a view of this. So then we need to make a parallel line, and then every information from other views. Okay, so the horizontal view and here the front view. So it should be make it like so. Make a 90-degree lines from every information from this view, and also from here make like this. And refer this one is using a compass, and make cross it, and you will generate auxiliary view. Okay, so like we open this, so it becomes like this. So same thing happening here. Okay, so why we need an auxiliary view, just again to understand. this side this side is inclined, is not parallel to the other projection planes. To see this one, okay, so that's the top view, and that's the front view, and top view, and the left and okay, right hand side view. And in this view we cannot see, so here we can see, but it's not true view. In here we cannot see. In here also inclined, because that is inclined, so we cannot see real view. So because here that's in reality that's a cylinder, but here is not cylinder again. So with this three view, first 1, 2, 3, okay, we cannot see. So what we do is we are making auxiliary view here. We are making auxiliary view. So we are making a parallel to this side, and then every information came from every sides, like every three view information. So we'll make measure and we generate this view. So that's auxiliary view. And also in this example, this side is inclined. So from this top view and from this front view, we cannot define this shape. So that's why we create this one. This one is auxiliary view. That's auxiliary view. So to see this one perpendicularly, to see this side perpendicularly. And also this one, we are looking from here, like we are seeing this view, that is front view, and we are looking okay, we are looking from from this side, and we are seeing this. Again, we are not seeing this side that is inclined, so we cannot see this side from the 90 degree. So to see this one, we are rotating and we are making auxiliary view here. That is auxiliary view. That's auxiliary view. That's auxiliary view. And we are seeing this information, this face 90 to the 90 degree. All others are rotated because of this one is we are seeing 90 degree. Okay, so to see this one, we made an auxiliary view. So